Right, so we will take one more example, which is x of t equal to minus e power minus a t u of minus t. Okay, so again we are not putting any condition on a. Okay, so let us try to plot this functions first. Okay, so minus e power minus a t u of minus t means definitely it should lie in which quadrant? Third quadrant. So let us plot that function. Again, we'll consider two cases. One is a greater than 0. Let's say a is 1. So this is e power minus t u of minus t multiplied with minus 1. E power minus t u of minus t will be like this multiplied with minus 1. So definitely he will look like this. Okay. So this is the plot of e power minus a t u of t when a is greater than 0. So similarly, how does the plot look when a is less than 0? When a is less than 0, let's say a is minus 1. So this is e power t u of minus t multiplied with minus 1. So e power t u of minus t will look like this multiplied with minus 1, and hence it looks like this. Okay, so this is the plot of minus e power minus a t u of t when a is less than 0. So for which case Fourier transform exists. So Fourier transform exists for this case, but Laplace transform will exist for both the cases. Okay, now let us try to find the Laplace transform for this signal. So x of s would be integral minus infinity to 0, correct? Multiplied with minus e power minus at e power minus st dt. So this should be equal to integral minus infinity to 0 minus, we will keep it out, we get e power minus at. With substitute s with sigma plus j omega, you will get e power minus sigma t e power minus j omega t dt. So that should be equal to minus integral minus infinity to 0. I'll write like this, e power minus a minus sigma t multiplied with e power minus j omega t dt. Okay, yes. Let us assume the term inside the square bracket to be some d. So how is that looking now? Yes, how is that looking at? That is looking like minus ctft of which signal? E power dt u of minus t. Correct. Why? Integral is from minus infinity to 0. You get u of minus t. Minus a minus sigma, we assume it to be d. First we'll talk about existence. When will this exist here? This exists only if this is looking like e power at u of minus t. Fourier transform of e power at u of minus t. When will that exist? That exists again when a is greater than 0, but instead of a we have d. Okay, only if d is greater than 0. But what is d? D is minus a minus sigma is greater than 0, or we say a plus sigma should be less than 0. Okay, I'll write or. Okay, so real part of s less than minus a. So when a plus sigma is less than 0, that we can write it as real part of s less than minus a. Means what? CTFT of e power dt u of minus t exists only if real part of s is less than minus a. So CTFT exists implies who should exist? Laplace transform should exist. So Laplace transform exists or Laplace transform converges only if this condition is satisfied, and hence we call this condition as what? Region of convergence of that particular Laplace transform. Okay, we'll write down that if the above condition is satisfied. Okay, so if the above condition is satisfied, what do we get? X of s should be equal to how much? Minus CTFT of e power dt u of minus t. So this is same as that should be equal to how much here? Minus 1 by e power dt u of minus t will have d minus j omega as the Fourier transform. Correct? E power at u of minus t will have 1 by a minus j omega. Instead of a we have d. Okay. But what is d here? D is nothing but minus a minus sigma. So let us substitute that. Okay, so this would be equal to minus 1 by minus a minus sigma minus j omega. Minus will get cancelled throughout and you get sigma plus j omega that can be replaced with s. So you will get 1 by s plus a. So x of s would be equal to 1 by s plus a. So Laplace transform of the given signal converges to 1 by s plus a provided which condition is satisfied? Real part of s is less than minus a is satisfied. Okay, we'll write down that e power a t u of minus e power minus a t u of t, that fellow also will have 1 by s plus a as the Laplace transform. But what is ROC here? ROC is real part of s less than minus a. So clearly what does it mean? If you look, okay, before we go to that argument, let us try to plot the region of convergence. Okay, once I say region of convergence, we have to go into S domain. So this is sigma and j omega. Okay, again we have a pole at where here? We have a pole at minus a. So let's assume a is greater than 0. So we have a pole at minus a. So what is the region of convergence? That is real part of s is less than minus a. So real part of s less than minus a means this shaded region would be the region of convergence. Means what? Only in this region Laplace transform converges. In the right side of minus a, Laplace transform does not converge. So you'll say it does not exist. Okay. Similarly, when a is less than 0, so what will be our pole 0 diagram? We have only one pole at where? Minus a. So when a is less than 0, minus a would be positive. So you will have something like this. Okay. And what is ROC? This is minus a. Okay. Yes. What is ROC? It's real part of s less than minus a. Again, that should be the left side of that line. Okay. So left side of that. So again, in the right side region, what will happen? The Laplace transform does not exist. Okay, so let us summarize now what we have got completely. Okay, last two examples, let us summarize. They are very important. That's why. Okay, what is that we have got? E power minus a t u of t will have 1 by s plus a as the Laplace transform, and ROC is real part of s greater than minus a. Similarly, minus e power minus a t u of minus t. This fellow also we got the Laplace transform to be 1 by s plus a. But what happens? The ROC changes, which is given by real part of s less than minus a. So what is that you observe here? We observe that we can have multiple signals with same Laplace transform, but where do they differ? They differ in region of convergence. Region of convergence are not same, even though the algebraic expression, I mean the mathematical expression for Laplace transform is same, but they differ in region of convergence. Okay, yeah, so please keep this in mind, and the corresponding examples are also very important. Okay, so let us conclude this lecture with first lecture of Laplace transform with examples related to the summary. Okay, so that you are okay with it. Okay, let's say find the Laplace transform of. Once I say Laplace transform, not only the equation, you have to give region of convergence also. Okay. First one, let us take x of t to be equal to, let's say e power minus 2t u of t. So what will be this fellow's Laplace transform here? This fellow will have 1 by s plus 2 as the Laplace transform, and ROC would be real part of s greater than minus 2. Okay, so let us try to plot the region of convergence. Signal we already know how it looks. So what will be the, this is sigma and this is j omega. So we have a pole at minus 2. Okay, so what will happen? ROC is real part of s greater than minus 2. So this is the region of convergence. Okay.